Okay, welcome to this next session. We have Sean DuBois here talking about one of the most exciting new projects in the WebRTC environment, which is Pion, which I'm really interested about, mostly because it breaks the so-called WebRTC monoculture that you may have heard about. So everybody uses LibWebRTC for everything, and it's nice instead to see a WebRTC stack that is done from scratch, building new things from scratch again. So please, Sean, amaze us now. Thank you.
I'll try my best. Well, thank you very much, and thank you for putting on this ComCon. It's fantastic to see such a focus on open source. So I'm Sean. I'm one of the original founders of Pion. Today we'll just talk about the WebRTC implementation. First off, even though I'm standing up here, I'd like to thank everyone who's contributed. It's very easy to see me as as working on it, but this is really what makes a difference. There's some people on here who've put in hundreds of hours, and some people who have done fantastic of telling, oh, here's a little bug and here's how to fix it. So this is a little out of date. We've had a couple of contributions in the past week, but yeah, this is the lifeblood of the project. So first off, what is Pion? Pion, it's sort of a collective for building RTC and peer-to-peer projects. There's no commercial ownership. I work on this on my personal time. It's not really a project that has any funding right now. I also don't plan on making any money off of it. I'd like to expand out in other places, but I'd like to see it owned by the community more than anything else. So how it works right now is if you commit to Pion and you merge something, you get a commit bit, and that's all it takes. And to merge to match, you just need an approval from another contributor. So all that it takes, in a week's time, you can fix a bug and be merged by someone who already contributes. And from then on, you can approve other people, and other people can approve you. So there's no deadlock on a single person merging PRs like me. Pion is not just WebRTC. Because everything is 100% in Go, we had to implement all these individual parts. So DTLS, ICE, turn, all these individual things. So this is quite an undertaking. And on top of that, this is available for other projects. I've seen a lot of small embedded devices like IoT want to use just DTLS or SCTP. And the other fantastic thing is there's many people who are very passionate about these individual technologies. We have one person who just loves DTLS. They want to implement all the RFCs. They know about it than anyone I've ever talked to. And so that's why what I really want to encourage is ownership of each individual parts and get the people that are passionate about them. I'm personally passionate about WebRTC as a whole. So it's great to see people jumping in individual parts. And there's other stuff in the future, like an RTP engine. So if some people just want to send RTP over UDP, like now we want to have a pluggable jitter buffer that's agnostic to whatever you want to do. It's still a growing community. So Pion's only existed for a year and a month or so. And in that time, we have about 45 contributors and 10 active. Large and small companies use it. We have a lot of startups where we have their CTOs. We have a lot of large companies where we have them pulling down with it in large projects and stuff like that. And diverse use cases, which is one of the ones that's most interesting to me, is I'll hear people doing the classical things that I'm used to. They're building another source and bringing it in and taking it out to WebRTC. And you'll have these really weird ones, like I want to make a customizable Raspberry Pi security camera system, which just was nothing I'd ever thought of, but it's great that we can empower use cases like that. So the community is not just for Pion. We have a Slack channel with like 250 people, and we'd love for you standards, other projects. Really, I'd like to just bring the WebRTC community closer together. I hear that people say it's hard to find one place to talk. And the second is the knowledge base that we're trying to work on. So because we implemented DTLS and all those things, we want to write down that deep knowledge, not just about the WebRTC API, but about how all those individual technologies work. So one of the first immediate benefits you'll notice is Pion is 100% in Go. So if you've ever written Go before, some of this will be boring, but if it's all new to you, hopefully this will convince you that Go's worth your time. Go fast. I would say performance somewhere between C++ and Java. And not just that speed that matters, but the speed of development. So if you've ever worked on build systems or anything like that, the nice thing is Go doesn't have any of them. If you want to start using Pion, all it is that second command is go get Pion WebRTC. It'll pull everything down, and because it's 100% in Go, it doesn't matter what environment. You can have a brand new minimal dead SID install. You can have a Mac. You can have any embedded system. It'll work. And it's also sub-2nd build time. So you pull that down, and the project's completely built. Go. And it's very easy to optimize. The nice thing is, which is so simple and fast, there's really not a lot to worry about. You just have to track allocations and make sure you don't do the usual bad things. Portable and simple deploys. If you're building WebRTC products, you've probably run into this before. You waste a lot of time debugging and testing. You'll have users say they have an individual issue and you want to deploy and have them test again. How do you do that if you have, it takes 30 seconds to deploy out? So all that it takes is setting those two environment variables, and from my Mac I can target Linux ARM. I can target Darwin, I can target anything I want. Just set those things, build your project, and it builds a nice stack binary, and I can deploy it on anywhere. We have people that are deploying to Android devices. We have people that are deploying to building little binaries so they can throw to Mac and Windows and Linux, because they have little desktop applications that are doing peer-to-peer. Maintainable, really important for an open source project. Because the language is so simple, you think about how we do software development at scale. Let's make it as simple as possible. If you know C, if you know Python, you probably can jump in and learn Go in a weekend. It's so easy to get other people involved in the project. So simple and opinionated. The other fantastic thing is the concurrency and cryptography. It's making it so easy to get started. And again, in that same vein, the language is opinionated. So because you don't have to worry about a large language like C++, that there's not a subset of Go that you need to learn, that you know the entire thing, that you can fit the entire language in pages of spec. Memory safe. So this is one that had a lot of impact on me. Chromium has this rule of 2. So the way that Chromium is designed, it's multi-process. So if you're doing some sort of traffic, you can't have it live in a high privilege situation. So you're not allowed to have user information and process foreign inputs in the same process, because it fails this rule of 2. So most of the time you'll process something and then you'll send it over RPC to another process. That's important because you don't want to expose user information. And you'll see this like recently with WhatsApp and the RTCP parsing. Go doesn't fall into the same trap. You don't have to worry if there's a bug in RTCP parsing or there's a bug in some other subset. The worst thing that happen is the entire application will, sig abort and throw out. You don't have to worry about what can come from that. And the other topic, fuzzing and code coverage, is something that other people have brought to the project, but it's very interesting to see, is how can we go in and make sure that even though we don't have to worry about these same types of problems, we still don't want these runtime crashes. So if you already know how to use WebRTC, you know how to use Pion. It's just like a Go implementation of the API you already know and love. Create offer, set remote description, tracks, pulling off ICE candidates. You already know how to use it. And my opinion is that when you come to a point where you're building your application, you're going to want to scale it. You're going to want to have to fit into these custom use cases. And this is why I'm happy that we adhere to this existing API. If you want to switch over to libWebRTC or AIO RTC, we should encourage that. Like, we should have that kind of flexibility so that people can use whatever project they want, and it makes every project better. And the other thing I've come to appreciate is the WebRTC API is well designed. You have all these things. You can design your own API, but then you'll see, oh, I need these specific stats, or I want to know something about, the RTC DTLS transport. You don't have to worry about reinventing the wheel. You don't have to worry about looking up this proprietary information about Pion. If you already know how to use WebRTC, these problems are solved for you. And then further, the actual definition of the project is it's split into subsystems. How often do you pull down a new version of a library and you find out that, oh, everything's fantastic, I have this great new feature, but there's a bug in ICE that drives me crazy, and how do I roll back? The nice thing of Pion is it's split into all these little packages, and so you can pull down, version 2.1 of Pion, but you can pin to 2.0 of ICE. So you can roll ahead, and you might not get the newest features in ICE, but at least you can keep rolling forward and be sure that the rest of it is working. And you can also add custom behavior. A lot of companies have these unique use cases that I want to empower. So let's say you want to do interesting, unique statistics about ice. You can use 99% of Pion's code base, but then just have your little custom ice component. And as long as you adhere to the same public API that we require, you can add any custom behavior you want. So you want to do analytics, you want to do some custom behavior. Let's say you're working with a WebRTC implementation that's busted, and you want to enable that. This enables that. And there's a little package graph that shows. So Pion WebRTC, it's really just using all these individual components and wrapping them up. So the main repo itself is a simple, take in the SDP and parse it, take in that, start it up DTLS, but because at the base, WebRTC is just a collection of all of these interesting, complicated protocols, but WebRTC itself isn't handling these parts. So these are one of the trade-offs that I think is worth making, but it'll be confusing coming from other implementations, is the media coding is dev controlled. So our API just emits RTP packets and consumes RTP packets. So if you're doing the coding yourself, and you're going to think about the things like how I need to emit another keyframe because there's been loss and stuff like that, you're going to have to do it yourself. But why that's important is it enables things like distributing pre-recorded content. There's a lot of these custom use cases that aren't enabled by existing WebRTC implementations. If I have a video file on disk, I can just open that with Pion, iterate the frames, and send it off. Those are the kind of use cases we want to empower. So even though we don't have the coding built in and you're going to have to listen to the feedback from Pion, it enables all these custom things. Like we have this project Gunk that does RTMP to WebRTC and HLS. And a lot of those use cases are really popular. Quick is another one. So right now we have quick support via ORTC. So it's not in the SDP and it doesn't work with Chromium. This landed in December before the Chromium version came out, but I'm working on moving over to the Chromium version soon. And then we also have features that don't find in WebRTC. So this was started by Hugo, and this is a fantastic idea, is we have all these things that aren't addressed by WebRTC yet. Like, how can we make that happen? And so so you can just pass to when you create a new RTC peer connection that you're used to, and have some of this proprietary behavior. So things like, I want to control how long until a host candidate, or I want to reject all host candidates and force server reflexive. This is where we let those things happen. I'm amazed at the unique use cases. We have people that are stuck with broken firewalls that, this port range doesn't work for some reason, and we have these. So there's about like 10 different flags or toggles, and eventually it'll add up. But at this time, I hope that we can push these into the WebRTC spec themselves. But these are a lot of these. And like the custom MDNS behavior I saw on the mailing list, there was talk about moving this into WebRTC itself. This is one that has saved me a lot of time, is user-defined logging. So because with libWebRTC, if you go to debug a certain issue, you can't really log in a certain subsystem. You can't dump that certain part. So with Pion, you can see an example at the bottom. I want to get a trace log of ice, but every other component, I just want to see all debug logs. So if you have an issue in ice, you can set one environment variable, and all of a sudden you can get a trace and print out all the ice packets, or DTLS or SCCP. Since every individual component respects these environment variables, it makes debugging incredibly easy. And it also doesn't have to go to standard out. It can go to any sort of user callback. So in the RTC peer constructor, you can specify, okay, here's this callback, and then you just have to satisfy, trace, debug, warn, and that's it. So a lot of people are setting out to their whatever logging system that they prefer. And WASM, this one I don't know enough. This was contributed by Alex, and the idea is you should be able to write your code in Go and then be able to target the browser as well. So one code base, you can target both. And I think this is fantastic. How many times do we write these custom signaling protocols, and we have an implementation in C++ and we have an implementation in JavaScript, and they're all broken in different weird ways. This will help keep your signaling code sane. So you only have to worry about writing it once, and it'll work everywhere. And it's like you already have this wide variety of platforms that Go targets, and the browser is just one more. So VNet is the idea that if you're frustrated with your application falling down in real-world scenarios, so to the Pion constructor, you can pass a topology, and on top of that, you can pass the network conditions. So you can say, oh, I have 3 peers, and one is behind a NAT, one doesn't allow TCP only, and stuff like that. And so you can set all of these network conditions, jitter and loss, and then you can run it, and just in software, you can simulate exactly the conditions that your application is going to perform under. You don't have to go out to the real world and try to set things on the, you have these nice applications that let you set on your own loopback these network conditions, but this will let you build complicated things. And this actually has helped us trace down a few bugs in Pion itself. In our test suite, we define like, here, I'm going to have 2 Pion WebRTC instances talk to each other over UDP, but we're going to drop 80%. And then you find weird bugs in weird places. It's fantastic for learning. I'm going to probably mispronounce this name, but Yutaka did a fantastic job of building this complicated system. Now I sit down and I see like, oh, what happens when I have 2 symmetric NATs talk to each other? My understanding of things has gotten so much better from being able to just simulate all this stuff instead of having to read it or hope that I can figure it out on my own. And then what are the use cases that Pion targets? The first one that you'll come to think of is like the standard WebRTC servers. So one of the saw was WebRTC G-Speech. So a user wrote this thing where you can sit down and it's just a single Go binary, /go, and run it. And it's a web UI. You hit start and I talk. It captures your audio over WebRTC and sends it to the Google Speech API and returns back what you sent. I mean, the best part is how easy the deploy is. It's a single static binary. The HTML is contained in it, and I just download it and it goes. You hit that start button, it sort of feels like WebTTY. So I think even though the media gets a lot of love, the data channels is what is going to enable a lot of interesting use cases. This one is someone built something so that you can share your terminal with a web browser, or you can have 2 terminals shared to each other over WebRTC. You really just have to share the STPs, and then you have 2 terminals that are provided to each other. So on the left and the right, if you wanted to help someone debug an issue in a remote data center, or you want to connect 2 peers to each other, this is how you do it. This is also great. At a lot of small companies I've seen, you'll have your SSH jump box. You'll SSH into a server on the outside, and then you'll SSH into the inside. This can be great. You don't have to expose any. You can keep your network a little simpler. And this is a project. How many people are tired of having to start X11 to jump into a conference call? ASCII RTC was a fun little thing that someone wrote where you can just download a single binary. It's statically linked. It works on Mac right now. Just type, /ASCII RTC, and you're popped up and you see someone else's face. And you have data channels as well, so you can talk to each other. I think it's great that there's this conception that WebRTC is really just for the browser. I really want to see more things that target not just the browser, but can use anywhere. And then RTC Tunnel is a project that someone wrote, and a while back, it was one of the first projects that was using Pion, and it was to build network tunnels from your browser to a backend, and really you're just tunneling TCP traffic in SCTP. And they had all these crazy cool ideas. So how nice would it be if you're trying to use a Redis server and all of a sudden you can just pop it open in your browser and via WebRTC influence the state of the server. And my idea, they talk about building a browser-based IDE. So instead of having to ship your state everywhere, here's your chance that you can own your own little VPS in a data center and be able to operate on it. And how fantastic would it be, how often do you don't want to download some binary and run it locally to test it, especially if it's like some open source project, you just want to see how it uses at the command line. Here's a dumb little one that I had fun for just my own fun. With 80 lines of Go, using an existing project for Go CV, I was able to do some basic image detection and show motion detection. And all I'm doing is really just I send the video buffers to Go CV, and then I take the video buffers back and display them to the user. And it sort of feels like magic that with only 80 lines, because Pion and Go CV abstracts away so much, that I'm able to do this. But there's so many cool projects you can do on the back end. You can do motion detection, you can do speech to text, all these interesting things. Here's one that's dear to my heart, is the cloud gaming. So someone wrote an NES emulator, and they ship the video frames back from the VPS, whatever data center you want, and then they send the key events to that. It's a fantastic little project. And I'm hoping that we can see it expand even more. It'd be fantastic. I think that internet connections get better and the technology gets better. We're going to see more things like this, and I'd love to see that the user maintains control of the software. I know there's projects coming out. The idea is that you'll rent a game from some company and then you'll play it on their servers. But here's an opportunity that we can build something that you maintain and own the software, but you still can play it in a remote data center. So getting started, we have a couple interesting examples. We have the normal, like the data channels example, where you plop two SDPs. The minimal SFU. So think about the API. If you wanted to build like an SFU in your browser, you would spin up two RTC peer connections. You would send your video to one peer connection, and then that peer connection would connect out to other people. That's really all that is. And then the Go CV we talked about, saving a disk. You see a lot of people that they want to do security systems and they want to slurp up that video and save it. And then we have built into the code base, we have IVF and Opus, so you can just use those. And then all these already popular and big open source projects like Janus and GStreamer, like how can you hook into these existing systems? And then the other nice thing is the Go doc. So with Go, you have since it's all static, you're able to just jump in and see the code exactly as it's defined. So you can go to godoc.org and see how Pion is driven and see the actual definitions of all the structs and all the configuration. So if you've ever written JavaScript, you know that it's sort of fluid. You have these great resources like the Mozilla Developer Network and other stuff like that, but it's not really a true source of information. It's something that someone has to write. The nice thing about this is generated directly from the code, so you can jump in and browse around, and it has this nice generated code output. And of course, Pion's an open source project, so we need you more than anything. Here's some interesting problems. I always have people ask, like, how can I get involved? These are the things that I'd like to see. So better congestion control. So we have congestion control in SCTP, and then we expect the user to do some of that on their own in the media coding. We'd like to see this RTP engine. So we've had a couple companies that have went and implemented themselves. We have to go and implement a good one ourselves. So we have like a basic static one, but solving that problem, having like a dynamic jitter buffer that can grow to latency. And I'd like to see something where you can pick one ahead of time. There's a lot of use cases where you think, oh, I don't care about packet loss because I want this, this needs to be real time, 200 milliseconds is a minimum. You have others who are like, I don't care, it can grow and shrink, but I need perfect video quality. And then another important one is getting that end-to-end testing, which is not one of the fun problems, but definitely some we need. And then web design and user outreach. I think we have a lot of Go developers, and we have a hard time finding enjoy design and building like beautiful web interfaces. We have a lot of people that like to jump in the channel, and the first thing like, how do I do things? And to me, it seems obvious because I've been working on the project, but I need that help of that user perspective on the outside. If you've never used Pion before, but you're interested in getting involved in an open source project, I think this is a fantastic opportunity to come and give your feedback and say, this is how you can do a better job of presenting information and helping people learn. And then we want to hear from everyone. I don't care if you're an open source project, if you have a company that you're trying to build a custom use case. You don't have to be, the conversation doesn't have to be in public. Feel free to email me personally, or feel free to send me a PM on Slack. I just want to hear from people so we can make the project better. I know a lot of people have come up to me in passing and told me they've used it. I'm always surprised at the interesting use cases, but I can't figure it out if I don't hear from you directly. So yeah, so that's it. Thank you very much.
Thanks, Sean. Any questions for Sean?
So just curiosity, does the WASM get compiled down and use the browser's implementation of the WebSocket, or does it still use the Go implementation of WebSocket?
Yeah.
WebRTP?
Yes. Yeah, it uses the browser implementation. So there's like we have these tags in the code base where at the top of the header we say like use the JS implementation or use our implementation. So yeah, we're lucky in the cases like the get user media and all that stuff, that all uses the browser implementation.
Yeah, okay, nice.
Well, I wasn't here right in the beginning, but you put up all the list of contributors, and you've got such a lot of contributors in quite a short time. So what's the trick with that?
Yeah, I think the biggest trick is giving people that ownership. So one of the things is when someone joins, they have as much commit right as me after the first time they commit. It hasn't burned me yet, and I really very much believe that that's the kind of model we need. I see a lot of people, they get burned out pretty quickly because it's friction added by me, and it's usually pointless friction. I stress and fret that the code they contribute isn't going to be good enough. But I think a lot of these things are a two-way door. Like maybe your first contribution isn't that great, but I know that as we go on, we'll just make things better and better. I think as long as the project moves quickly and we test rigorously, we can avoid that. I think a lot of times, a lot of the stress about bad contributions comes from the project itself not having great testing or great infrastructure. And I was really guilty of that at first as well. When Pion first started, a lot of times a user made this great contribution, this big commit that fixed a lot of things, but added another bug, and we got all stressed out and acted like it was a big deal. But the reality of the situation, you just need to fix it quickly and catch these things early.
Any other questions? Then let's give Sean a big round of applause. Thank you.